Hello and welcome to the next video in my pre-algebra review series. Today's video reviews Chapter 4, Section 7, entitled Exponents and Multiplication. By the end of this video, you should have a better understanding of multiplying powers with the same base and how to find the power of a power, or in other words, a power raised to a power. Please leave a like if you have found this video to be helpful. And if you'd like me to cover any aspect of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Thank you. In Objective 1, multiplying powers with the same base, we are going to look back to Lesson 4.2, where we learned how to use exponents to indicate repeated multiplication. So what happens when you multiply two powers with the same base, such as 7 squared and 7 cubed? Well, 7 squared times 7 cubed is equal to 7 times 7 times 7 times 7 times 7. That's 7 squared times 7 cubed. And the answer is 7 to the 5th power. Notice 7 squared times 7 cubed is 7 to the 5th, and that is 7 to the 2 plus 3. We added the powers. We added the exponents in this case. In general, when you multiply powers with the same base, you add the exponents. And a key concept here to remember is multiplying powers with the same base is to multiply numbers or variables with the same base, add the exponents. Arithmetically, it looks like 2 cubed times 2 to the 4th is equal to 2 to the 3 plus 4 power, or 2 to the 7th. And algebraically speaking, a to the m times a to the n, notice the a's are the same base, gives you a to the m plus n power for positive integers m and n. In example 1, multiplying powers, they ask us to simplify each expression. So in the first expression, we have 3 times 3 cubed. And what is that? That's 3 to the 1st power times 3 to the 3rd power, or 3 to the 1 plus 3 power. So you add the exponents of the power in the same base. When you add that, you get 3 to the 4th power. And if you simplify it, you get 81. 3 to the 4th power is 81. And in the next problem, b, a to the 5th power times a times b squared gives us a to the 5th times a to the 1st times b to the 2nd. And that equals a to the 5th plus 1 times b to the 2nd, or b squared. You add the exponents of the powers with the same base, and a's are at the same base. You can't add the b in because the b's have a different base. B is different than a. And you simplify it. You get a to the 6th, which was a to the 5 plus 1 equals a to the 6th, times b squared. And that's your answer. That's as far as you can go. For example 1's check your understanding, they give us 3 problems they'd like us to work on here and simplify. The first one is 2 squared times 2 cubed. So 2 squared times 2 cubed. And that is equal to 2, as we learned earlier, 2 to the 2 plus 3. And that equals 2 to the 5th power. So 2 squared times 2 to the 3rd, or 2 cubed, is equal to 2 to the 2 plus 3. And 2 plus 3 is 5, so it's 2 to the 5th power. For b, we have m to the 5th power times m to the 7th power. And that equals m to the 5 plus 7 power, and that equals 5 plus 7 is 12. So it's m to the 12th power. How about c? C, we're using two variables here at this time. So we have x squared times x cubed times y to the 4th power. So we can take these like bases. X's are like bases. Y's are like bases. So we can multiply x to the squared times x cubed and get x to the 2 plus 3 power times, now we've got the y's, this is y to the first, right here, y to the first, so y to the 1 plus 4 power, and when we've solved this out, we get x to the 5th times y to the 5th. That's the answer on this one. In example 2, we're using the commutative property of multiplication to help us sort out the numbers that we're multiplying, and we can move them around to make it easier to group them together to get the final solution. So in this case, we start off with minus 2x squared times 3x to the 5th power. Well, we have some numbers in here and some variables. So what we can do using the commutative property is we can take here, we can sort this out, because you can multiply each of these and drawn out like this, and then we can move them around. So we can move the 2 and the 3 to the front, okay, and then we can bring and put the x's together. So it's by separating them and moving them around. And then when we do that, we can say, oh, we have minus 2 times 3, and then the whole thing is times x to the what? To the 2 plus 5. X to the 2 plus 5, which is 7. And then when we resolve this down here, we get the minus 2 times 3 is minus 6, and times x to the 7th. So x to the 7th. Same answer. So now we're going to check our understanding of this commutative property of multiplication. So to start off, we're going to take the 6 and the 3 and bring them together. 6 times 3 times a cubed times a, which is a to the first. And then when we work this out, we can say 3 times 6 is 18. And then we have an a cubed, and an a to the first power is equal to a to the 3 plus 1 is equal to 18 a to the 4th power. Let's go to B. We have a couple minus signs here now, but it's not going to matter. So we have a minus 5, and we have a minus 3 times minus 3. So we can put little parentheses around here if we want to. And then we can say times c squared times c squared times c to the 7th power. So when we work this out, we have 15 minus times minus is positive 15, because the negatives, two negatives make a positive, times c to the 2 plus 7, and that's equal to 15 times c to the 9. 15c to the 9th. And I'll write that again, 15c to the 9th. I want that to look like it was getting low there. Okay? And as for problem C, we're going to move the 4 times the 3 to the front, and we're going to take times x squared times x to the 4th, And here's a little problem I'm running into by looking at the x's. Just kind of dawned on me as I'm looking at this. That with the x's here, pretty soon you're not going to know whether this is an x or this is an x, is the times, or the x is the times. So often we can either put parentheses or we can use a dot. That's pretty common to use a dot. So when we multiply this out, we're going to get 12 times x to the 2 plus 4 power is equal to 12x to the 6th. That's the answer to this problem. So for objective 2, finding a power of a power. So we start off by saying you can find the power of a power by using the rule of multiplying powers with the same base. For example, 7 squared times, or not times, excuse me, 7 squared raised to the 3rd power. So what is the common base? We're going to say the 7 squared is this common base. So we have 7 squared times 7 squared times 7 squared. As you see that we use the 7 squared as the common base. And then that ends up being 7 squared, and we add the exponents. 7 squared, so 7 to the 2 plus 2 plus 2. And when you add those together, we get 7 to the 6th power. So notice that 7 squared to the 3rd power is the same as 7 to the 6th power. And 7 to the 6th power is the same as 7 to the 2 times 3. So we multiply. When you raise the power to a power, you multiply the powers. In this case, 7 to the 2 to the 3 is equal to 7 to the 2 times 3. So that's 6, 7 to the 6th power. And the key concept of finding a power, to find a power of a power, multiply the exponents. Arithmetically, it would be like 2 to the 3rd to the 4th power, which is 2 to the 3 times 4, 2 to the 12th power. Algebraically, it'd be a to the m raised to the nth power, and that would be a to the m times n. This is for positive integers, m and n. It doesn't work when you use negative. Okay, let's try an example here. Simplifying powers of powers. For a, we have 3 squared cubed. So 3 squared cubed is 3 to the 2 times 3 power, because we're multiplying the exponents. And that equals 3 to the 6th power. And 3 to the 6th, if we're going to simplify this expression, we have to go all the way to something that, in the simplest form, 729 is 3 to the 6th power. If we look at b, a to the 6th power squared, or to the 2nd power, is a to the 6 times 2. If you look here in the red, it's a to the 6 times 2. And we're multiplying them, and we get a to the 12 right there. So in example 3, we'll do check your understanding one last time, I think it's going to be. So for a, what do we get? We get a is equal to 2 to the 4th times 2. 2 to the 4th squared. And that is equal 2 to the 8th power. And what is 2? Since it's a number, what is 2 to the 8th power? Well, you probably don't know that off the top of your head yet, but in the future you'll realize that that's 256. A very common number when you get into computer mathematics. For b, we have c to the 5th raised to the 4th, which is times 2 to the 5th times 5 to 4 here. So c is equal to 5 times 4 is, c is equal to, excuse me on that, 5 to the 20th power right here. And m cubed raised to the second power is m cubed times 2. The 3 times 2 is equal to m to the 6th. So it's really not hard. You look at the exponents and you multiply them. You multiply the 5 times the 4. You multiply the 3 times the 2. 4 times 2 is 8. 5 times 4 is 20. And 2 times 3 is 6.